So let's take a look at Super Bootstrapper. Now, I should have mentioned, you note that all of these reports are stored as a tab in this. It's actually a notebook object, and it just goes on and on. You may say, well, gee, Jeff, that's a little strange, but also they are automatically printed to your disk. So if you go to the reports folder now, you'll note that there are the 11, you can kind of see them highlighted, the 11 original PLS path modeling reports, including the 5 bootstrapping reports. You see all these permutation reports in the middle, and there are 24 of them because it estimates it computes the difference between at least a minimum of 2 groups for 8 different variables: path coefficients, weights, loadings, the direct effects, which are the same as the path coefficient, indirect, total effects, then the latent variable scores is number 7, and then finally the R-squared value, giving you quite a bit of metric and structural and variance information about the inner model and the measurement model. Okay, so that's 8 reports if you have 2 groups, but if you have 3 groups, you get 3 reports for each variable, group 1 and 2, 2 and 3, 1 and 3. So you get 24 reports. Okay, that's what we see here. Let's just open up a couple of them. Okay, so I'll highlight this many and I'll just say open. They're CSV files. And so they open up in Excel. Okay, this is the loadings for 1 and 3. You can see the header up here. Note again how very easy it is to open up these reports to get output. You could bold the headers and the rows there, and you can say format, auto fit column, and then if you don't like these really long precision numbers here, you can do there's a shortcut actually. You could do this. Make it whatever you want. Okay, and immediately you get a publishable report. I mean, the quality is very good. It's better to edit it in something else than try to. Now the graphics are all PNG. They're pretty good, and there'll be a lot more of them. Okay, so let's go to Super Bootstrapping. I didn't really go hog wild on the bootstrap capabilities in the PLS algorithm itself because I figured I could improve on it by starting from scratch, basically, my own bootstrapping algorithm. And that's what I did. This doesn't use any other functions. What it does is it runs PLS over and over and over again, but it looks at the distribution, the computed distribution from the resamples of every parameter that gets estimated. And I believe there's 16 of them now. Let me show you. So we hit Super Bootstrapper. It's going to run PLS, but that's not the report we're going to get. We're just going to get the significance reports. And so let's say we do want to scale. We want to produce both summary and detail. The summary just tells you if it's significant. The detail gives you a record for each resample. We do want to save it. So right now we have 24 plus 11 plus 3. What is that? 24 plus 11 is 35 plus 3, I think, is 38 reports and graphics on disk. Okay, so and this you can go up to 100,000 resamples. Maybe that's too much. 5,000, you might want to do 5,000. Let's just do 100 because we don't have a lot of time. So we say go, and it is pretty quick, really. By the way, the centroid inner weighting scheme is much faster. The path weighting scheme maximizes the endogenous variables, but it's more labor intensive. So it's producing the reports. We don't even see them. Let's cursor on over. if we click up here, note this with the application, you can right click on the bar and it gives you a count. So right now we have 69 different tabs. We have 66 different reports that have been output, including the Super Bootstrapper, and 3 graphics. So you get quite a few outputted reports. So let's go over here to the Bootstrapper reports and see what we have here. Bootstrapping is probably a better overall resampling technique to use with non-parametric data because it has a number of advantages and some disadvantages. There's more variability. It's very good with large data sets. Jackknifing has some attributes as well. Okay, so let's look. Bootstrapping is probably the preferred approach, and there's evidence that both the bootstrap and the jackknife will converge, but you have both anyway in this application. So here are, let's go back to the beginning. Path model. Okay, so here's the path model bootstrap summary. So it's showing you for these paths, these paths, here are the paths, all the paths in the model. In fact, they don't even fit. There are 11 paths in this model. There we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This is just for the path coefficients in the inner model, the direct reports, the direct effects. You get the coefficient. This is from bootstrapping it 100 times. You get the mean of the bootstrap, the standard error of the bootstrap, the t-statistic. This tells you, and the p-value. The p-value tells you whether this path coefficient is significant. The only one that is not is in this model is this one. Has from telepresence to perceived usefulness, very low t-statistic, and the p-value is not significant. But it also gives you confidence intervals, 95% confidence intervals, both normal confidence intervals and percentile. Normal can have bias. They're not going to differ much, but I put them both in there anyway. What you're predominantly interested in bootstrapping is whether the parameter that's being estimated is statistically significant. And you really get that right here in this line. Okay, so this is the p-values for whether the coefficients of the coefficient, which we see the estimates up here, are they different from 0? Are they significant? Okay, but you get it not just for the path coefficients, which you see here. You get it for the loadings, all 26 of them, which note when you run out of space in the notebook on the individual pages, you get the ability to cursor on over. Loadings, weights, 4 LV scores, standardized latent variable scores. Note that with the standardized latent variable scores, you don't expect them to be significantly different from 0 because these are the standardized scores, which means that they range from -3 to +3. They're standardized, they're mean-centered, which means if they are significantly different from 0, something's probably wrong because the mean score should be 0 and it should have a variance of about 1. And you see that here. None of them are significant, but that's what you would expect. You have direct effects. These are the same as the path coefficients, and they should be highly significant. But with Super Bootstrapper, here's an advantage. All of the indirect effects are automatically calculated to see if they're significant or not. And there are only 3 indirect effects in this model, but it gives you the t-statistics and the p-values for the indirect. So very useful. as far as okay, the total effects. You get the significance of the total effects, which is direct and indirect. You also get, for the average variance extracted, you get, you expect them to be different from 0 for sure, but you get the confidence intervals, which is probably useful. R squared, you get the same thing, the confidence intervals. You also get all of these other figures, all of these other parameters. You get the confidence intervals for them, the redundancy, the communality, Cronbach's alpha, Dillon-Goldstein's rho, first eigenvalue of the first eigenvalue of the principal component, second eigenvalue of the principal component of the GOF figure. Those are all the summary reports, 16 of them, one for each of those parameters. And the ones you're going to be interested in the most probably are the path coefficients, weights, loadings, direct effects, indirect effects, total effects, maybe the latent variable scores, maybe the R squared parameter, but you have everything. Then you get the detail reports. So detail, here's in our path model. What that means is we ran just 100 bootstraps. And this stuff's coming because I'm filming while I'm showing you the app. It's not in the app. You get one for each bootstrap. So if you ran 5,000, you get all of the records, all 5,000 resamples, which can be useful, or you can ignore it. Okay, so you get 16. You get reports on the significance, the bootstrap significance and confidence intervals for 16 different parameters in your estimated model. Everything that's there, basically. And the detail reports. Now let's, before we go on to Super Jackknifer, now if we look in our reports folder now, here are the permutation ones. You see it's growing quite quickly. Okay, so, and I regard this as an advantage of this add-on tool or this extra tool. These reports are useful. It gives you plentiful reports that you can copy and paste into your documents, and it outputs them automatically. So you don't have to save them or do anything if you don't want to. Okay, let's look at jackknifing next.